Okay, I may make some references in this to Elves or Keebler's Cookie Factory. There's a previous video on this that may help clear that up if you're having trouble with understanding what I'm referring to. So does the relation represent a function, and this is important, from A on to B, which means into my factory, I have to have elves in charge of A's and B's and C's coming in there. And what they're able to do is turn those into any options from zeros to ones to twos to threes to come out. But I do have to have an elf assigned to A's, B's, and C's. So in this first one, we'll just call this 1. In number 1 here, um, I have an elf who grabs an A and is charged with turning that into a 1. I have another elf that grabs C's, and I tell that elf, you turn C's into 2s, but later on I tell that elf, you turn C's into 3s, and I have an elf in charge of the B's, and that's good, so they're all covered. Turn those things into 3s. So the question, is this a function? This is not a function because of this. So this is a no. I would call that elf confusion if you watched the previous video. But if you think of that in terms of the vertical line test, somewhere on the x-axis there's a value c that is trying to be at 2 and at 3, and our vertical line test fails. So number 1, not a function. Number 2. A's are taken care of. They're supposed to turn things into 1s. B's are supposed to turn things into 2s. The elf in charge of C's turns those into 3s. A, B, and C are each taken care of. There is no elf, the elf in charge of A's, B's, or C's, that should be confused about his or her job. So number 2, yes, is a function. Number 3. In this case, if we didn't look at all of the above and they just asked, is this relation a function? I would say yes, this is a function. 1s turn into A's, 0 turns into A's, 2s turn into C's, 3s turn into B's. No confusion. You might say, well, what about this? Nope, it's not confusing that 1s get turned into A's and 0s get turned into A's. It's just coincidental. That's not like what we had going on up here where we said, you turn C's into 2s, you turn C's into 3s, where we don't know what to turn a C into. If we put in a 1, we know what we're getting out. If we put in a 0, we know what we're getting out. So in that respect, it would be a function. However, this is a function from B to A, not from A to B. We need to receive A's, B's, C's, turn those into 0s, 1s, 2s, 3s, and or 4s. So this is a no under the stipulation A to B. However, if there's an elf in charge of C's, turn them into 0s, and that's all C's ever get turned into. B's get turned into 0s, that's all B's are being turned into. And A's into 3s, that's all A's are turned into. Yes, that is a function. Okay, then determining whether the equation represents a function. There's an algebraic and a visual or graphical way to handle this. If we recognize this thing as a sideways parabola, and we may not know exactly how it looks, but it is most definitely a sideways parabola, no matter which direction it opens, it fails vertical line test. Whoops, that's not much of a vertical line. It fails the vertical line test. So this thing would not be a function. Algebraically, if we were to solve this thing for y, we could get x minus 1 equals y squared, or then y equals, when we take the square root, careful, plus or minus x minus 1. Think about that for a moment. Any value other than 1 that I choose for x, so let's say I put 3 in there, this becomes 2, but then it turns into 2 values. So 3 would give me 2 values. It gives me 2, but 3 would also give me negative 2. That is not a function. So algebraically, in the process of solving for y, if you can conveniently solve for y, you get a plus or minus. This thing cannot be a function. So is this a function? No. Number 16, graphically. You may or may not know that graphically, this thing looks something along the lines of this. That's the square root function shifted to the left 5. If you recognize that, it's a breeze. Vertical line test passes. This thing is a function. Then go back to what I said algebraically. If we solve for y, well, y is solved for. And we have to introduce a plus or minus. There is no plus or minus. Then yes, it is a function. So this is a yes. Graphically, do we know what this looks like? Well, we would if we maybe added y to both sides and subtracted x. We could pretty quickly come up with that sketch. Looks something like that, and that thing passes vertical line test. Hope I've been saying vertical line test. In the process of solving that for y, I never came up with a plus or minus, so yes, this is a function. Number 20, once again, here we have a sideways parabola due to the y squared, or solving this for y, we would get y squared equals negative x plus 3, or y equals plus or minus square root negative x plus 3. Therefore, nope, not this one. Okay, let's think about this graph just for a moment. Y equals absolute value of x. A quick t-chart. Put in 0, get out 0. Put in 1, get out 1. Put in 2, get out 2, etc. Put in negative 1, get out 1. Put in negative 2, get out 2. So if y equals absolute value of x looks like that, we would expect x equaling absolute value of y to be sideways. How sideways? I don't know, but it really doesn't matter whether it looks like this or like this. It doesn't pass vertical line test. Now, in solving this for y, well, what if we had something like this? Let's say absolute value of a equals 9. If absolute value of a equals 9, then a could equal plus or minus 9. So it stands to reason if absolute value of y equals 4 minus x, y equals plus or minus 4 minus x, and there we have it. Any value, in this case, other than 4 that I choose, for instance, 6, if I choose 6, I get 4 minus 6, negative 2, but I also get 4 minus, 4 minus 6, negative 2, the opposite of negative 2, too. So that's certainly not a function. So we're finding when we solve for y, if we get a plus or minus, this thing cannot be a function. Determine whether this equation is a function. Well, y equals 8. I started becoming pretty good at graphing these things when I quit thinking of this as y and I thought of this as a height. The height is always 8. Height is 8, height is 8, height is 8, height is 8, height is 8. That is most definitely passing the vertical line test. So yes. However, algebraically, if we can solve for y without introducing plus or minus, well, it's already solved for y, no plus or minus. Yes, function, most definitely. This is a factory that makes 8s. Okay, I would refer to some of this sometimes as like a Midas muffler shop, where G is the factory, that's our Midas muffler shop. When we drive our car into there, it puts our car here, and up on its walls there's 7s and minuses and 3s in multiplication. But whatever our car looks like, this or this or this, it gets driven into here. So g of 0 is 7 minus 3 times 0, 7. G of 7 thirds is 7 minus 3 times 7 thirds, course, that's 7 minus 7, 0. And g of s plus 2 is 7 minus the thing, or 7 minus 3 times, excuse me, the thing, s plus 2. So that is 7 minus 3s minus 6, or negative 3s plus 1. Pretty simple. Okay, here's a piecewise function, and I take a look at this like this type of a factory where a little taller here, because there's two options of things I can do as x enters. Depending on the value of x, I'm either running down this little conveyor belt where they're taking things, squaring them, and adding 2, or I'm running through this conveyor belt and out that exit where it's 2 times x squared plus 2. So in my mind, I'm seeing a little elf here in charge. And first thing this elf is doing is determining whether the value is bigger than 1 or smaller than 1. If it is smaller than or equal to 1, we go here. If it is greater than 1, we go down there. So negative 2 enters. This guy's job right here is say this is a negative 2. It is less than 1. We're going here. Negative 2 gets squared. We add 2. So we get 4 plus 2, 6. When 1 comes in to this factory, 1 is less than or equal to 1, so it goes to this factory. 1 squared plus 2, 3. But when 2 goes into this factory, the elf says, well, 2, you are bigger than 1. We're sending you down here where the bigger than 1 numbers go. And we get 2 times 2 squared plus 2, or 2 times 4, 8, plus 2, 10. And this again is called a piecewise function, where we break things into pieces. Okay, find all real values. Here's the mistake I used to make on this. I used to just say, well, I guess I'm driving 0 into my factory, but 0 is not going into the factory. X is going to the factory. What's coming out is 0. So f of x is 0, is 3x minus 4 on 5. And now an Algebra 1 student can handle this for us. Either cross multiply 5 to the 0 or say, well, if a fraction equals 0, the numerator must be 0. So x is add 4, divide 3. Find the domain. This is a bit of a sticking point for some people. We have to consider in our factory, is there anything that might go into our factory that breaks the factory down? We wouldn't want to do that. So things typically to look for would be these. We can never divide by 0, and we can't take an even root, square root, fourth root, sixth root, etc., of a negative, unless we're introducing imaginary numbers, and we're not there right now. So I just go through step by step. Can I add 2 to any number? Yep. Can I subtract 10 from any number? Yep. Can I take the square root of any number? No. Y minus 10 has to be bigger than or equal to 0 for me to take the square root. So y has to be bigger than 10 or equal to. And then last, can I divide any numbers I want? Well, I can divide any numerator I want, but the denominator can't be 0. Therefore, y cannot be 10. And I can consolidate these two into just plain old y must be bigger than 10. That's our domain. Kind of weird to talk about domain with y, but that's what they're telling us we're putting into. Y is actually our input value. Okay, likewise, I just go step by step. Can I multiply 3 by any number I want? Sure. Can I add 5 to any number I want? Sure. Can I divide by any number I want? Yes, the numerator can be any number, but the denominator, in this case y plus 5, cannot be 0. Therefore, y cannot be negative 5. So here's a case on the left where we state our domain by what is allowable, and on the right, we state our domain by mentioning what we cannot put into the factory. So I would say we have a little sentry guy out here. He has a little stop sign he's holding, and he's just waiting for somebody to bring something bad. So if somebody tries to deliver a 5 into this factory, he's not going to allow it. Okay. All right. This guy right here, you are going to get pretty comfortable with this in the coming weeks. But you'll notice in your book, next to problems 87 through 92, excuse me, let me close this guy out. You'll notice in your book, next to problems 87 and 92, you might have a little symbol like this, and that says this is going to be something that's going to be big and useful in calculus. But we're going to be debunking this. There's a real meaning behind this, and that's why you're going to see these repeatedly. So hang in there about a week and a half, and we're going to be going through this. Um, so we have a factory where we take things, put it here, put it here. So in that factory, I have squareds, I have subtraction, I have twos, I have multiplication, but I have to take something into the factory. The first thing I'm going to take into the factory is x plus h. So x plus h goes here, gets squared, goes here, gets multiplied by 2, and those subtract. That is just f of x plus h. Minus f of x. Well, f of x is explicitly this guy. All on plain old h. Seems weird, especially when you start doing multiple problems like this, but hang in there. So now we can pass this on to a reasonably decent Algebra 2 student, where we would FOIL x squared plus 2xh plus h squared. We would distribute minus 2x minus 2h. We would distribute minus x squared plus 2x. There's a big gotcha for people from time to time. Distribute that all on h. So does anything good happen here? Well, I see I've got an x squared minus an x squared. I've got a minus 2x and a plus 2x. And I see my remaining terms. I have a 2xh plus an h squared minus a 2h, all divided by h, and there we go. I can cancel an h numerator and denominator, and I get 2x plus h minus 2. And there we have it. Probably worth reviewing that. For whatever reason, that tends to give some people some problems, but we'll be taking a look at more of those. So hope that's helpful for you. Here's your assignment from section 1.2 in the event you're taking this. If not, if you're just visiting this website, welcome. Please stay tuned. Hopefully this was helpful for you as well. Thank you all.